the distance between the end projectors through the endpoints of a line capital AB is 60 mm and the NDA is 10 mm above HP and 15 mm in front of VP and the NB is 35 mm in front of VP. The line capital AB appears 70 mm long in the front view. Complete the projections, find the true length and its inclination with HP and VP. So the NDA is 10 mm above HP. So when you look from the front view, we can see the distance 10 mm above HP. And when it is projected that point onto the vertical plane, you will going to get 10 mm above HP in the vertical plane. Similarly, 15 mm in front of VP. So in front of VP will going to be seen in the top view because this is the distance which is in front of VP in space. When it is projected, that point will going to lie on the horizontal plane. So you are going to get this as small a. And this distance will be the in front of VP. Then the NB is 35 mm in front of VP. In front of VP will be seen in above HP. In front of VP will going to be seen in the horizontal plane. When you look from the top view, you can see the distance in front of VP here. So when it is projected, that point will going to be will be on HP. So from XY line, you measure the distance of 35 mm and draw a horizontal dash dot line, which will be 35 mm in front of VP in horizontal plane. So and then you write this as the locus of B in the top view. And the distance between the end projectors through the endpoints of the line capital AB is 60 mm. So since we have the locus of B in the top view, so the distance, when you look from the top view, you can see the distance between the end projectors in the top view. So from this projector A, you measure a distance of 60 mm and draw a vertical projector which will going to cut the locus of B in the top view. So you mark that point as small b, then join small a and b with a dark line. Then the distance between the end projectors is seen in the front view also from in the vertical plane also. So from the projector A, you measure the 60 mm and draw a vertical projector in the front view. Next, we know that since we have the top view line on this end projector only, we will going to get the front view because that is the distance between the end projectors. So the line capital AB appears 70 mm long in the front view. So with A dash as center, take the radius of 70 mm, cut on the end projector line so that it will going to cut the end projector at this point, which will going to become B dash. Then draw a horizontal dash line, which will going to be the locus of B. Then join A dash to B dash with a dark line. So now we have the top view and we have the front view. Now we need to find out the true length. So when it is projected, when from B dash, when you draw a vertical projector which is in front of VP, and also from small b, when you draw a vertical projector which is distance above HP, both will going to intersect at this point. So this will going to be the capital B, and join A to B with a dark line. This is in space, so this will not be there in the sketchbook, but it is there in the 3 dimension where this is the actual line. This will be position of the actual line. Now since we need to find out the true length in the vertical plane first, so with A as center, you take the radius of AB and rotate it such that B which was here will also be in front of VP by 15 mm. With A as center, take the radius of AB and rotate it such that B will be in front of VP by 15 mm, so that both capital A and capital B1 will be in front of VP by 15 mm. So that means it is parallel to VP. Since it is parallel to VP, so you are getting the true length in VP. So you are going to get this point, this line, A dash B1 dash. Then join A dash B1 dash with a little bit darker than the projector line. So this will be the true length. But when it is projected in the top view, you can see on this will going to be parallel to VP in the top view. You can see that is in the horizontal plane. So when you are rotating in space, the image traced by this will be on the horizontal plane. With A as center, you take the radius of AB, rotate it such that it makes parallel to VP. That means small AB1, both are in front of VP by 15 mm. Since both are in front of VP by 15 mm, so therefore obviously that point will be true length. In that line will going to be the true length in the front view. This is quite evident here. So then draw a vertical projector from B1 to the xy line, and then from this point you draw a vertical projector till it cuts the locus of B in the front view and mark that point as B1 dash, then join A dash B1 dash. Since this line is parallel to VP, so you are getting the true length, so you mark this as capital A and capital B. So then this will going to be the true inclination with respect to HP, which will going to be called as theta. Now, similarly, now we want to find out the true length in HP. Since the true length in HP means that line has to be parallel to HP. So which is the line which we can consider the line which is inclined to HP. So which is the line which is inclined to HP? The front view, which is A dash B dash. So that is this this capital AB, which is in space. When you want to rotate, when you want to make this parallel to HP, with A as center, take the radius of AB, then rotate that B such that B will going to be that B2 will be above HP by 10 mm, and so that both A and B2, A and B2 both will go to be above HP by 10 mm, so that you will going to get the true length in HP. Since the line is parallel to HP, when you look from the front view, this line both A and B2 will be above HP by 10 mm, so that means it will be parallel to HP. Since you are looking from the front view, so when it is projected, you will go to get that line which is A dash B2 dash, which is above HP by 10 mm, and this image will be on the vertical plane. So when you that is when it is parallel to HP. So when you look from the top view, when it is projected, so that will be projected onto horizontal plane with small a and B2. So join A and B2, which will going to be the true length, which will be thicker than the little bit thicker than the projector line. So then we will be able to find out the true inclination with respect to VP, which is 5. Now, so when you are rotating in space from with A as center to rotate the point B such that B2 is above HP by 10 mm, but the image will going to be on the vertical plane when you look from the front view. So from A dash with A dash B dash as the radius, you draw an arc such that B2 dash and A dash will be above HP by 10 mm. So this is parallel to HP. So then we will going to find the true length in HP. So the true length in HP can be seen in the horizontal plane. You can see here. So from B2 dash, you draw a vertical projector to the XY line, and from there again you project that to the locus of B in the top view, so that you will go and cut the locus of B at small b2. Then join small a and b2 with a little bit thicker than the projector line, so that will going to be the true line. So you are determining the inclination with respect to VP, which is 5. So this is how we will be able to analyze the three-dimensional sketch. Now we will going to solve this problem in sketchbook. First we will going to draw the XY line and mark VP and HP. Then the distance, the NDA is 10 mm above HP and 15 mm in front of VP. So from the XY line you measure 10 mm above HP, because the image is seen in the vertical plane. Vertical plane is above XY line. So draw a horizontal line. Then similarly 15 mm in front of VP is seen in horizontal plane. So from XY line we measure the distance of 15 mm in front of VP, which will be on the horizontal plane. Then draw a horizontal line. Then consider any point and draw a vertical projector so that it will going to cut A dash and A in the top view and front view respectively. Then the end B is 35 mm in front of VP. So in front of VP is seen in HP. So HP is below XY line. From the XY line measure 35 mm and draw a horizontal dash dot line, which will going to be the locus of B in the top view. Then the distance between the end projectors through the end points of a line AB is 60 mm. So you have the projector A. From this projector A, you measure the distance of 60 mm, which can be seen in both vertical plane and the horizontal plane. So then draw a vertical projector such that it will going to cut the locus of B in the top view, because we are already having the locus of B in the top view, and mark this point as B. Then join A to B with a dark line. Then you extend this projector line in the front view, that is above the horizontal plane, and we don't have this locus of B in the front view. Now first we know that the line capital AB 70 mm appears 70 mm long in the front view. That means the front view of the point B dash should lie on this end projector. So you measure this by using the compass. You measure the distance of 70 mm with A dash as center. Cut an arc on this end projector line so that you will going to get the point B dash Then mark that point as B dash and join A dash B dash with a dark line. Then draw a horizontal dash dot line here, so which is going to be the locus of B in the front view. So now we have the front view and the top view. Now we have to calculate. Now we need to determine the true length and its inclination with respect to HP and VP. Now first we are going to consider the top view. So when you want to find out the true length in vertical plane, you have to make the line parallel to VP. Since we need to make the parallel to VP, the line which is inclined to VP has to be made parallel. So with A as center, take the radius of AB. By using the compass, you rotate it such that AB1 is in front of VP by 15 mm, so that it will be parallel to VP. Since it is parallel to VP, so you are getting the true length in VP. So from B1, you draw a vertical projector so that it will going to cut the locus of B in the front view. So that point will going to become B1 dash. Since this line is parallel to VP, so you are getting the true length here. So you mark this as capital A and capital B and join A dash B1 dash with little bit darker than the projector line. So and name the true inclination with respect to HP as theta. Similarly, now you take the front view line with a 70 mm. With A dash as center, take the radius of A dash B dash and rotate it such that both A dash and B2 dash will be above HP by 10 mm. So that this will going to be the parallel to HP. Since it is parallel to HP, so we are getting the true length in HP. So then from B2 dash, you draw a vertical projector which will going to cut the locus of B in the top view, so that you will going to get the point B2, small b2. Then join A and B2 with little bit thicker than the projector line and mark that inclination with respect to VP as phi. So since this line is parallel to HP, so we are getting the true length in HP. So we will write it as capital A and capital B. So by using the scale, you measure the true length, which will be 72.80 if you are doing it in CAD. If you are doing it in manual, it will be 73. And similarly, by using the protractor, you measure an angle true inclination with respect to HP, which is theta, which will be 30 degrees when you are doing it in manual. When you are doing it in computer, it will be 29.69. And similarly, you measure the inclination with respect to VP, which is equal to phi, which will be 15.95 degrees when it is doing it in CAD. When you are doing it in computer, when you are doing it in manual, it will be 16 degrees. So this is how we will be able to find the solution in the sketchbook. Now we will going to analyze this by step. In this first step, what we have considered is first we have taken above HP and also in front of VP of the point A, and similarly the end point B is in front of VP by 35 mm, and he has given the horizontal distance between the end projectors. So we have drawn this so that you are going to cut the locus of B here. So you are going to get AB, which is the top view. Then since he has given the front view appears to be 70 mm, so the front view point of B dash should lie on this end projector, so that you are going to, by taking the radius of 70 and cut an arc, so that you will going to get this point B dash. So then join A dash B dash with a dark line. So we have the front view and we have the top view. Now we have to find the true length in VP. So you make the line, the top view line you make parallel to VP. So you are going to get AB1, which is parallel to VP. So when it is projected into the front view to the locus, so you are going to get B1 dash. Then join A dash B1 dash, which will going to be capital A and capital B. So this is the angle with respect to HP, which is theta. So that is what we have shown here. That means we are rotating the top view point. So we are rotating the line which is in space when it made parallel. So the image will going to be traced by here. So since this line is parallel, when it is projected, you can see this is parallel to VP. Since it is parallel to VP, so you are getting the true length here. So this is the inclination. Similarly, when you are considering the front view, you may take the front view and rotate it and make it parallel, so that A dash B2 dash will be above HP by 10 mm. So since it is parallel, so you are going to get the true length in HP. So you make that B2 dash to be projected such that it will going to cut the locus of B in the top view, so which will going to be B2. So join AB2 with little bit thicker than the projector line, and this is the inclination made by this with respect to VP, which is phi. And also the true length will going to be same in both in front view and as well as in the top view. So this is in three-dimensional. Also we can see that capital A and capital B, which is in space, you rotate B such that it may be such that B2 will be above HP by 10 mm and A is also above HP by 10 mm. Since that line is parallel to HP, so when it is projected in the top view, we are going to get the true length here directly. So this is how we can be analyzed both in the stepwise and also in the final solution. So what exactly you need to write in the final examination is only this particular set, and these are only for understanding the concept. Thank you.